AWS security credentials are used to authenticate and authorize requests to AWS resources. Managing and keeping them secure throughout the development process is important. In all my previous videos, I have been hardcoding the AWS credentials when connecting to different AWS services. Even though I duly call out that it is not a recommended practice, I have not touched upon the good practices when managing credentials in code. In this video, let's learn different ways to set up and manage credential information when building .NET applications on AWS. We will also look at tools and utilities that you can set up on your local development machine to make working with AWS and .NET easier. My name is Rahul and welcome back to this YouTube channel. If you're new here, I work as a senior developer in Austix, an Australian ticketing company based out of Brisbane. In this channel, I make videos on .NET, Cloud, and DevOps. Without much delay, let's jump right into learning more about credential management and how to use it when building .NET applications. If you're new to AWS and playing around to learn more about it, I highly recommend checking out the AWS free tier and setting up an account for yourself. This enables complete access to your account and you can play around very easily. I use this for my videos and also for my learning purposes. Now, once you have an account set up with AWS, the initial email and password you use is often referred to as the root account. Now, it is highly recommended that you create another account, which you could call as an administrator account, that you use for your daily administrative purposes. As you can see here, the recommendation from AWS is to avoid using the root user account to access management console and services. Don't forget to enable multi-factor authentication for both these accounts. If we navigate to my AWS console under IAM, we can see that I have two accounts set up. Under users, you can see an administrator and also another for my console application. Both of them belongs to an administrator group, which also I have set up in this particular account. Now this is something you can do if you're setting up a new AWS account by all yourself. With the basic environment setup done, let's navigate to Visual Studio and start writing some code. So let's create a new project and select AWS Lambda in this particular case. Now I'm choosing AWS Lambda just for the ease of deployment. Everything in this video is very much applicable to any .NET application that you would be building for AWS or connecting to AWS resources. So let's continue with the AWS Lambda project and click Next. Let's give this a name. So let's call this as AWS-Credentials and click Create. It prompts to select a template which allows different AWS Lambda functions. In this case, I will choose empty function. Now, if you're new to AWS Lambda and want to learn more about it, you can check out the video linked here or in the description below. Now with the empty function selected, let's click Finish. This creates and sets up a basic AWS Lambda function. In short, a Lambda function is simply a piece of code that can run in the AWS environment. Now you don't need to understand the mechanisms of AWS Lambda for this video. With this project created, let's go into the Solution Explorer and you can see two files inside here. We have the functions.cs and also the AWS Lambda tools defaults.json. This is mostly required for deployment and also to run the mock Lambda test tool on your local environment. The functions.cs is where the source code is. Now once we navigate into that, this has a simple function which takes in a string input and returns it in uppercase. Now let's say in this function, we need to connect to an AWS SQS and send some messages into that. So let's head off into the AWS console and create a new AWS SQS queue. Think of this as a simple queue where you can drop messages and can be consumed by different applications. Now if you're new to it and want to learn more about it, you can check out the video linked here or in the description below. Now under the simple queue service, let's click Create Queue, select Standard and give this a name. Let's call this as YouTube-demo. Let's leave all the settings as default and click Create. Now this creates a new queue inside our AWS account in the Sydney region, which is AP Southeast 2. With that set up, let's come back to our code and start sending some messages to that. For this, we first need to create a client. This needs to be an instance of new Amazon SQS client. This comes from a NuGet package, so let's use Alt-Enter and Visual Studio uses type inference and gets the NuGet package. So this is coming from AWS SDK.SQS NuGet package. It automatically installs this. The constructor has multiple options, one of which takes in the credentials and the region endpoint. So let's pass in the credentials and also the region, which is going to be the Amazon.region endpoint. So let's specify region endpoint. Make sure to include the appropriate usings and select the AP Southeast 2, which was Sydney that we just saw. Let's make sure to define the credentials object. So let's say where credentials is equal to new basic AWS credentials. This allows us to pass an access key and a secret key, which we will get in a moment. So let's leave that as blank for now. Now, once the client is created, let's call the send message to send a message to the queue. Now, this takes in a request object, which is of type send message request. So like before, let's define the request object and let's define the request right above this. So let's call this as new send message request. Make sure to include the appropriate usings and specify a few properties on this request. It requires the queue URL and also a message. So let's specify message body. Now this could be simply the input in this particular case. For the queue URL, let's navigate back to the queue and copy the URL from the console and paste this inside here. Now the request is created and also the message is sent. Now since this is an asynchronous method, let's make sure to add the await call. Now this prompts us to make the method async. I'm getting these pop-ups by hitting Alt-Enter or Control-Dot, which is a shortcut in Visual Studio for me, and say make method async. If we want, we can also capture this response and use this in our response back. So let's say instead of simply returning the input, let's use string interpolation. Let's capture this input inside that. And let's also return back the response.status code so that we know if the call was success or not. Now in this function, it simply takes an input, it connects to the AWS SQS and sends a message and sends back a string message. Let's now see how to set up this basic AWS credentials. For this, we need the access key and the secret key that can connect to this Amazon SQS. When building applications, AWS has some guidelines on how to use the credentials. It specifically calls out not to use the root credentials to access the AWS resources. The root account again is the main email ID that you use to create the account. It also recommends not to put the keys in the application files. Let's navigate to users and create a new user. So let's call this as YouTube demo. Select access key because that is what we want, an access key and a secret key. So let's click next to the permissions. We can add the user to a group if we want. So we could create a new group and specify YouTube-group. So any users that needs access can be added to this particular group. So let's click create group, which will create the new group and assign this user automatically to that. Let's click next. If you want to have tags, you can enter that here, but otherwise let's click review and create the user. Now this creates the user, which gives us the access key ID and also the access key. So let's copy this and let's also copy this at the same time. Once we navigate back to our application, let's paste the access key ID and also the secret key. So I'm using Windows and V to open the clipboard manager and select the value that I want to paste. We have the basic AWS credentials set up, but this user still doesn't have access to this particular queue. So let's navigate back into the console. Let's close this. Let's navigate to the user groups and select the YouTube group that we created. We can give permissions to this group, which will be applied to all the users in this particular group. So let's navigate to permissions and select add permissions. And we can create an inline policy for now. So let's choose a service. We are interested in connecting to an SQS, so let's search for that. Here, you can specify different access levels that the application requires for this particular action. Now in this case, I'm only using the send permission, so I could literally come here and say write and just select the send message option. With that selected, let's specify the resources that these actions is applicable for. So let's click the resources and add in a specific ARN. Now we have the ARN for the queue. So let's navigate back to Visual Studio. Let's copy the region from here and also the name of the queue. So we have both of that in our clipboard. So let's navigate back. Let's paste the queue name and use the clipboard manager and paste the region and click add. Now the send message is applicable only to this specific resource. Let's say review policy and create a policy name. So let's specify YouTube demo-sqs-policy and click create policy. Now we have the permissions to send the message to this queue, and this is applied to this user as well. So if we navigate to the YouTube demo user, we can see the permissions and see the policies under that as well. This is coming from the group that it is attached to. With all that set up, let's come back to our application. Let's make sure to run and see if this is working. Now when we made this as an asynchronous method, it automatically changed the function name. Let's revert that back because the Lambda function will be looking for this particular method, which is configured inside the AWS Lambda tools.json file. So let's revert the name back and run this to see this in action. Let's also put a breakpoint and press F5. Now this opens the mock Lambda test tool. So let's select an input for this function. Let's say hello and click execute function. Now the request is coming in. You can see the input is hello. So it's creating the message request, sending it to the message and returning back the response to this mock Lambda test tool. So if we look here, we can see the response which says hello and OK, which is the status code. If we navigate to the AWS console, let's go into AWS and go to the queue that we have created. So let's navigate to YouTube demo, select send and receive messages and say poll for messages. You can see the message that we've just sent right here. So you can see the body is hello. Now this could be used by other applications to process it, but that's shown in the SQS video that I've done a while back in this channel. As you can see, we have hard-coded the credentials inside the application code. Now this is usually where I say it is not recommended to do this, and for demo purposes I'll be keeping like this and moving on. But let's see what are the good practices in managing these credentials when building .NET applications. We will see two different ways to solve this problem in this video. First, I will show you how to move this into an application configuration file, which is normally the app settings.json file that .NET by default has. This is particularly useful when you have applications which is running outside of the AWS infrastructure and wants to connect to AWS resources. Next, we will see a different and a more improved approach if you have your applications running in the AWS infrastructure itself. You can use the default credentials that's set up for your environment based on where your application is running to get connected to these services. So let's see both of these in action. First, let's move this into an application configuration and see how to set this up. So let's navigate to the Solution Explorer. Let's right click and say add a new file. So let's click new item and specify a JSON file in this particular case and call this as appsettings.json and click add. This creates a simple JSON file inside our application. Let's add two keys to this configuration. So let's call this as access key. Let's also add a secret. Now if your application needs other configuration values, you could add that here as well. So let's simply add one more which says a prefix message. So let's say prefix and specify that value as hello. Now for the access key, let's navigate back to our function, remove this and paste it inside here. Let's also remove the secret from here and paste it inside the app settings file. So we have moved both of them to the app settings.json. So let's come back to our source code and start reading it from there. To read from the configuration file, .NET supports a default configuration builder. To start using that, let's specify config. Let's create a new instance of configuration builder. So if we use Alt-Enter, it will prompt us to install the Microsoft.extensions.configuration NuGet package. With that installed, let's make sure to set the base path that this needs to look for this particular configuration. So let's specify base path and give this as directory.getCurrentDirectory. So this is going to look for the current directory for any of the files that it needs. We also need to add the JSON file, which is coming from appsettings.json file. So let's specify appsettings.json file. Now, these requires a few more NuGet packages. So let's go into the Solution Explorer because Visual Studio is not by default recognizing which type it requires. So let's right click and specify Manage NuGet Packages. Now let's go into Browse and search for Configuration. We need the configuration.json NuGet package. So let's click Install. We will also need the configuration binder. So let's install that while we are here. So let's click OK and we have both the packages installed. Let's come back to our function and continue writing our configuration builder. Now both of these functions are resolved appropriately. With the JSON file added, we can call the .build. This creates a configuration object that we can start using to retrieve the values from this particular file. So let's read the access key and the secret from this configuration. So let's specify access key, specify config.getValue, which is coming from the binder. So let's specify this is a string value and give in the key that's required. In this case, this is access key because that is the name that we have used in appsettings.json. So let's come back and also specify retrieving the secret. So let's press Ctrl D to duplicate this line, rename this to be secret, and rename this key value to be also secret. So we have both the access key and secret. So let's use that when we are building the basic AWS credentials. So let's specify access key and secret. We had also added this prefix inside this particular configuration. To retrieve that, let's duplicate this line again and specify prefix. And instead of the key secret, let's specify prefix. We can use this prefix inside our return message here. So let's specify prefix and the input that we pass in. Now, this prefix could be any other application configuration that your application or the function code requires. I have just used this to show this as a demo. Now, with all that set up, let's navigate to Solution Explorer, right-click on the settings file, and click Properties. We need to make sure this file is copied to the directory so that whenever it looks for this in the current directory, this file is present there. So let's change this to Copy Always. Now let's build this application to make sure it's building fine. Let's put a breakpoint here and run this again. The mock Lambda test tool is running. So let's pass in a request. So let's specify Lambda and click execute function. Now there's breakpoints here. So let's step over this and we can see we get the access key, the secret, and also the prefix as we've defined in the configuration file. So let's continue the execution and this drops the message into the queue and returns back the response to the Lambda function. We have successfully moved this into the configuration file. But this configuration file is again going to be checked in with our source code, and this still has the secret and the access key as plain text inside it, which is also not recommended. We have just moved it from function.cs into the appsettings.json file. To make this secure, let's move this into the environment variables. To make the configuration builder read from environment variables, we need another NuGet package. So let's right-click, specify Manage NuGet Packages, and add for the configuration.environment variables. So let's click Install and select OK. Once that's set up, let's come back to our function. Right after the add JSON file, let's call add environment variables. Now this also looks for the environment variables and updates any of the configuration values provided there. Now the order of which we specify these configuration providers is very important. So first it looks at the appsettings.json, picks all the configuration values, and then it overrides it with whatever it finds from the environment variables. So anything with the same key will be overridden as it goes down the chain. Now if you're new to configuration in .NET, I highly recommend checking out my video, which will be linked here or in the description below. With that set up, we could move this particular secret into an environment variable. Now using the environment variable is more easy when we are deploying to a Lambda function. To set this up on a local machine, it's more effort involved. So in these cases, in local development environment, we can use the .NET feature which is called the Secrets Manager. So with Secrets Manager, let's go into the Solution Explorer, right-click on our project and click Manage User Secrets. Now this creates and adds a few NuGet packages which we will be using again in our application. So let's click Yes, which creates the secrets.json file. If you look at this file, this is under my roaming directory under a user secrets with a random GUID on it. This file is not checked in as part of our source code. If you're new to Secrets Manager and want to understand more about this, I highly recommend the video linked here. So now with the secrets.json, we can easily move this particular secret value inside there. So let's copy that and paste it inside this. Let's come back and remove the value from the secrets in app-settings.json. Now the app-settings.json doesn't define the secret, which is the sensitive information out of these three. This is moved into the secrets.json, which will be used from here. Now to make our application look in the secrets.json, we have to come and add a new configuration source provider. Now the secrets manager should be coming right after the JSON file because we want the environment variable to take precedence if that exists. Add user secrets, which is automatically installed when we enabled Secrets Manager in the project. This also requires a type name where the Secrets Manager is configured at the project level. So since we created in the same project, we can pass this function class as the type name. So it will take the Secrets Manager configured for this particular project where this function class belongs. Now with all that set up, let's click Save and make sure to run and see this in action. We have the Lambda test tool. Let's select Secrets Manager and click Execute Function. Now this hits the access key, which it gets from the app config. Now the secret is now coming from the secrets.json file because we don't have that in the app-settings.json. So the value in app-settings.json, which was empty, was overridden by secrets.json as soon as it saw the Secrets Manager configuration builder. Since we don't have anything specified in environment variables, it doesn't override that. So let's check the prefix and continue execution. So this successfully drops the message and returns back to the Lambda function. Now we have successfully removed the access keys from our application code. With that done, let's make sure to deploy this into the AWS Lambda and see how this works there. So let's right click and specify publish to AWS Lambda. Let's give this a function name. So let's say YouTube-demo and click next. Let's make sure to give a minimal role access. So let's select the AWS basic execution role and click upload. Now this zips the AWS Lambda and uploads it into my AWS account. The Lambda function is successfully uploaded. So let's navigate into the AWS console. Let's go to the home page and select Lambda from there. Now we can see the YouTube-demo which we just deployed. So let's navigate into this. Now we need to set up the environment variables for this Lambda. Now based on your application type, configuring the environment variable would be different. But for a Lambda, we can come under configuration, select environment variables and add in the keys here. So let's click edit and add this environment variable. Now we need the secret to be coming from the environment because we don't have the Secrets Manager inside the Lambda environment. The Secrets Manager is used only for local development purposes. So which is why we also add the environment so that can be used to override the values in app-settings.json. So with the secret, let's paste this from our clipboard manager. So let's paste the value from here. Now AWS Lambda currently has an issue when working with Secrets Manager. It currently crashes because it's trying to look for the Secrets Manager file. So in this particular case, the fix here to specify a home directory to /var/task. This is the default directory where Lambda has access to. Even though the secrets.json file wouldn't be there, this workaround is required to get this to work. So let's copy this and also make sure we are adding the home environment variable. So let's specify home and paste that directory. Now this is not using anything from Secrets Manager, but this is just to get that particular library working while in production environment. You could also use #if statements and make sure that Secrets Manager is enabled only in the development environment. But for now, let's come back and add this environment variable and click Save. Now with those two added, the application has enough information to run this and drop the message into queue. So let's go into test. Let's remove this message and specify from AWS and click test. Now the Lambda is successfully run. It's automatically picked up certain values from app-settings.json and also the secrets from the environment variable. So if we expand this, we can see hello from AWS and see the OK response. So if we navigate to our queue service here, if we open that in a new tab, go to simple queue service, select YouTube demo, send and receive messages, and poll for messages, we can see all the messages that we have sent. The latest one being from AWS. Let's click done. So we have successfully removed the hard-coded values from our application and moved this outside of it. Now this method is particularly useful when you have applications that is running outside of the AWS infrastructure. But when we have the applications running within the AWS infrastructure, we can use the power of default credentials, which is provided by the environment where it is running on. Now, when I deployed our Lambda function, I did that from the AWS toolkit. But if you would have noticed, I was able to successfully publish to my account. This is because I have the AWS credentials set up in my computer. Now you can see there is a profile YouTube which has access to this particular account and which is enabling us to deploy these functions. So how is this credentials set up? These credentials are coming from the AWS credentials file. Now by default, this is located under my user profile under the .aws folder. So let's copy that and let's open this in Visual Studio Code. So let's press Windows and R to open the Run tab, specify code and pass in the path we just copied and click OK. This will automatically open that particular folder in Visual Studio Code. Here we have the credentials and the config files. Now this has the default profile and also it has the profile YouTube. So if you look at the credentials, there are two different sets of credentials inside here. Now this has access to deploy things into my account. So you can either manually add something into this or you can also add this using the AWS CLI. Now I'll put a link on how to install the AWS CLI in the description. Once you have that installed, let's open a new console and we can use the AWS configure method to set up these credentials file. So if you specify AWS configure, and if we want to specify a specific profile name, we can specify -- profile. And in this case, let's say YouTube demo and press enter. Now this creates a new profile. So it's asking for an access key ID. So let's navigate back to our source. Let's close this. Let's copy the access key ID from here. Let's also make sure to copy the secret into the clipboard because we will need that shortly. So let's come back to the terminal and paste the access key ID and press enter. Now this prompts for the secret key, which we already have in the clipboard. So let's select that and paste it inside here. So let's press enter. If we want, we can specify a default region name. So if we come back to the config, here there is the region name, which is the AP Southeast 2, and come back to the terminal and paste it inside this. You can also specify the default output, which is by default none. So let's press enter. And this creates a new configuration profile inside my local profiles. So if I come back to these files, look at the config, you can see there is a profile YouTube and also the profile YouTube demo. The credentials for these would be inside here. So you can see there is a YouTube demo that's created automatically inside this particular file. Now I have 3 credentials. So if I navigate back to Visual Studio and go to the Publish tab, you can see all these credentials inside the AWS credentials. Click the drop down and you can select the profiles from here. But if I was to select the YouTube demo, this does not have access to deploy anything. So this would be throwing an error if I was to use this to deploy something inside my account. So if I click next, this is going to say it doesn't have the required permissions to deploy because all it has is to send the message to the SQS queue. So I'll have to use a profile that has the appropriate permissions. So let's close this. Now the .NET applications can also use these profiles that's saved on our local computer. So if we can navigate to the functions.cs, if we comment all this secret and access key, and if we also comment out the AWS credentials and remove it when we are creating the SQS client. So let's remove both of these and it uses the default constructor. When we are using the default constructor, it will fall back to the configuration that's stored on our computer. So let's see this if this will work in action. So let's make sure to clear these breakpoints. Just have it right here and click F5 again. Now the application is running Let's send a message, let's say test, and click execute function. Let's step over the request and let's see if this is able to send the message. So if you look at the response, we can see this is the status code OK, which means the request was successfully sent. Now, the Amazon SQS client is by default resolving the credentials from that is configured in my account. Now, this by default will be using the default credentials that is configured in this account because I haven't specified a specific profile name to use in the application code. Now, Visual Studio doesn't allow me to step into these functions and to see what is happening internally. So for that, let me switch this over to Rider IDE, which is provided by JetBrains. So I have the solution opened in Rider. So we have the same function.cs. So let's put a breakpoint in the where client call and press F5 on Rider. Now this again opens up the mock Lambda test tool. So let's click Rider and specify execute function. Now this hits the breakpoint. So if we expand on the client, we can see this uses the credentials, which is again the basic AWS credentials. So if we expand this, we can see an immutable credentials and we can see the values as the AKIA and that ends with NOI. This is exactly the value that's set up inside my default profile. In this case, I have the YouTube profile also having the same keys as the default. I was just using this for test purposes. Let's continue the execution. If we want to see what's happening within the Amazon SQS client, let's put a breakpoint here and run this again. So let's click debug, which again opens up the Lambda test tool. So let's say internals and click execute function. Now this hits the breakpoint. So let's press F11 inside here. Now Rider allows us to navigate into the source code of that particular SQS client. So here you can see there is the fallback credentials factory from which it is trying to get the credentials. So let's press F11 again, which further navigates into the get credentials call. And we can see this is using another get credentials method. So let's navigate into that. This first looks for the cache credentials, which it doesn't have any, and it loops through the credential generators. So if we go to this definition, we can see the different generators that is defined inside here. So you can see here that this is using a few different types of generators and it will loop through all of these to find a credential. Now if we step over the function, you can see the first one fails. So this throws an exception because it was not able to find a specific environment variable and it goes to the next generator. So in this next generator, this is where it is actually going to get it from the credential store. So if we navigate in, you can see it's getting an environment profile name, which by now is empty, and it gets the credentials from this profile. If we want to override the profile name, as we can see in the fallback credentials factory and inside this particular code, we can see that this was looking at an environment variable, which is basically AWS underscore profile. So if we set up an environment variable, it will be using this particular profile name. So to set that and see it in action, let's come to properties, select launch settings and add in an environment variable here. So this is using the mock Lambda test tool Rider configuration. So let's specify the environment variables and specify the profile name and give this as the profile that we have created. So if we navigate back, we have the YouTube demo profile. So let's use that and save this and run this again. So this is again launching the Lambda console. So let's specify the profile and click execute function. Now this hits the breakpoint again. So if I was to step over this and expand the client and look at the credentials inside here, this time it's going to use the one that ends with NWP. This is exactly the one that we have used as part of our YouTube demo inside our configuration. Now it is using this particular profile because we have specified the environment variable, which is coming from launch settings.json in this particular case. Now, as you have seen, these configurations are in plain text inside our profile location. But if you're building .NET applications on Windows, we can store this in a secure credential store. So if we navigate to Visual Studio, if we navigate to AWS Explorer, so let's go to AWS Explorer and click the Manage Profiles or Add Profiles button. Now the icons here are missing, which has an existing bug for this particular toolkit. But let's click the Add and this prompts up to create a new profile. Now this by default is selected to be the shared credentials file. This is the same file that we were updating. But this also has an option to use the .NET Encrypted Store. So let's give the profile name as YouTube demo, and we can paste in the access key. So if we copy the access key from here, so let's copy this, paste it in here, and also copy the secret key. So let's copy this and paste it inside of here and click OK. So this creates a new profile inside the secure store. Now this is a Windows only feature, and by default it is located under the user profile in the registered accounts.json file. So let's copy that, open the Run tab and navigate to this file. Here you can see that these credentials are now by default secured. So this is encrypted and stored in this file. So once you have set this inside the secure store, there is no way you can get back these values from the IDE or if you navigate to that file. However, you can use this from the .NET application as well when you're running locally. So if we come back to our profile, let's remove this from the default profile here so that it's coming from the secure store because it has the same name. And let's remove in the config as well. So let's remove the profile YouTube demo and save this. Now if I was to come back into Rider, let's debug this again. This time our shared credentials file doesn't have this particular YouTube demo, which is set in our launch settings.json, so which is the environment variable, but this is going to get it from the secure store. So if you press F11 and go into the credentials and step further into that, when it is trying to get the AWS credentials, it is going to look at the secure store as well. So if we look at this try-get profile method, we can see here this is looking at the .NET SDK credentials file. Now by default it looks at that first and then goes to the shared credentials file. So this time this is going to get these values from the secure store. So now if we expand the client, look at the credentials, we can see that this is again using the one that ends with NWP. This is successfully coming from the secure credential store because we had removed it inside this configuration file. Now if continue the execution, this is going to run successfully. Now how this is going to work in an AWS Lambda environment, because we are not getting the secret key and the access key from the configuration file, but based on the environment permissions. So let's right click and deploy this to Lambda. So let's choose the default account which has permissions to deploy this, and let's click upload. Now the current code is using the default credentials based on the environment. So let's go to the Lambda. So let's specify from default and click test. Now this is going to fail because right now we haven't configured permissions on this particular Lambda. So it says it has an access denied exception when trying to request for this particular resource. To grant access for this Lambda to talk to the SQS, let's go into the configuration, let's go to permissions and edit this particular Lambda execution role. So if we navigate to that, we can add an inline policy for that role as well. So let's select add permissions, say create inline policy. Let's choose the service like before, give this as SQS. Let's specify the action to be write and send the message. Let's specify the resources and select the specific ARN. Now we have the Amazon SQS ARN from the SQS right here. So let's copy this, come back and paste it inside here and click add. Now this gives access to this specific resource and has the send message access. Let's click review policy and let's give this a name. So YouTube lambda.sqs policy and click create policy. Now we have successfully granted the Lambda permission to talk to this SQS. So if we come back to our Lambda function and refresh this, we should be able to see this under the resource summary. So if we expand here, you can see there is an Amazon SQS and this has the send message permission. So let's come back to test and try sending this message again. So let's update a value and let's say with permissions and click test. Now this time the message was successful and it returns back hello with permissions and OK. Now we have completely removed the need of the access key and the security key inside the configuration file and using it from the environment based on which it's running. Now, if it is a different AWS .NET application, you can configure similar permissions based on the role that it's running under. So if we navigate to the SQS queue, send and receive messages, and poll for messages, we can see all the messages that we have sent up until now. So if you see the latest message, you can see the one with permissions. I hope this helps you to understand more about credential management with AWS and when building .NET applications. First, we saw how to move the configurations into the app settings.json file, and then we saw how to use Secrets Manager and also read from environment variables. This is particularly useful for applications running outside of the AWS infrastructure. For applications running within the AWS infrastructure, you can use the power of IAM roles based on which the application is running. We also saw how to configure this and get this working on your local development environment, and also using the .NET SDK Secure Store so that these security keys are not visible to anyone. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, don't forget to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.